Hello, this is how I program for KDE using CLion and kde-builder. I have kde-builder already installed and configured. I have built the KDE application kcalc. And now we're going to install the integrated development environment JetBrains CLion. This is my wiki and mariusp.github.io. I'm going to the KDE wiki community.kde.org and the space for my user and mariusp. In here I have a page about JetBrains CLion. How I install JetBrains CLion is that first I install the JetBrains application toolbox. It offers a TGZ. I extract it and there's just one executable in there. It's going to install JetBrains Toolbox in the correct place, and then the Toolbox application is going to be available in your Start menu. And when it's running, it's going to also be available in the system tray. You will need to log in with your user because the application CLion requires a JetBrains account. So it's not a community version such as IntelliJ IDEA Community Edition or Android Studio or PyCharm Community. Let's find it here, install CLion. It's downloading and it will install it in the correct place, which is a certain directory in my home directory. And then this application JetBrains Toolbox has the advantage that it installs the application CLion correctly. It knows how to upgrade the application. It will offer you the option to install the latest version. There will be an update button. There's also the possibility of reverting to a previous version of CLion, and then it allows you to install additional JetBrains applications, such as the ones that I have used previously, PyCharm Community and Android Studio. We'll be back once CLion is installed correctly. I have a YouTube video about how to install JetBrains Toolbox. So it's a tar gzip, you extract it, there's an executable in there, you run it. It's a graphical user interface application, so written in Java, but already contains a JRE, Java Runtime Environment. Shows a graphical user interface wizard, where you will need to accept the EULA. Is going to get installed into tilde/.local/share/JetBrains Toolbox. And then the integrated development environment, such as CLion, that you install using JetBrains Toolbox, will get installed in a similar place, tilde/.local/share/JetBrains/toolbox/apps. I prefer to install CLion like this because, for instance, I can also uninstall it easily by just going to the JetBrains Toolbox application. I select CLion, the three dots button, and then uninstall. I can go to previous versions of the application. I always know when a new version is available. Very handy, centralized place to manage your JetBrains products for Linux. The application JetBrains Toolbox, I would recommend. Okay, so we have CLion installed. Now we have in the Start menu both JetBrains applications. There's JetBrains Toolbox, and then there's CLion. It remember that I had JetBrains CLion installed previously. Now I don't need the system tray application JetBrains toolbox, so I can right-click on it and quit. Let's open CLion again. And this time it should start fresh. I have just deleted its configuration directory. I had CLion installed previously. This is the directory that I have deleted, ~/.config, and the entirety of the JetBrains directory, because I only had the subdirectory CLion 2025.1 in there. With this, we have a fresh installation of CLion without any user settings. Skip import. We have the welcome wizard. So let's see what it says in here. We're not importing anything. We have the license already configured inside CLion. Another advantage of using the application JetBrains toolbox, because you provide your JetBrains account to the JetBrains toolbox application that decides what applications can be installed on your computer, and then it also licenses those applications. So it decided that based on my JetBrains account, I am entitled to use CLion. It has installed CLion, and then it has configured CLion to use my JetBrains account and license. Yes, so I have in the start menu CLion 2025.1.4 across platform C and C++ ID. Okay. So I have used the kde-builder, it's configured correctly. Let's prove that we have the CMake build configuration debug. So that would be the configuration file ~.config/kd -builder.yaml. And I have the CMake build type equals debug, which means that I have full debug symbols. The debug symbols were not stripped from the binary files, .so files, and the executable files, and that also full debug symbols have been generated, and no optimizations, which means that I'm going to be able to debug the generated binaries correctly, and the debugger will not jump erratically all over the place because various code blocks have been inlined, and the C++ optimizer has done some restructurings of my source code in the optimizers. I have built kcalc, and now we're going to build kcalc again, but this time we're not going to do git operations. We're not going to build any of the other KD Git repositories or other dependencies of the kcalc KDE application. And we're going to do a as clean as possible build. And we want full output from the KDE builder to the console. So let's do that. We can just copy the command line. What am I doing? When you Control-Shift-V twice, you get the coloring terminal escape codes, and that will not be great. Okay, but we don't need to have the command line finish. We can stop where the CMake configure step starts. So this was the compilation step. And this is the CMake configure step, this part. So says running CMake targeting Ninja, correct? And then we have the directory ~kd/build/kcalc, the command line that's going to be used, and the environment variables that have been configured before running the command line cmake space minus uppercase b space dot space minus uppercase s, etc. We're in the Welcome to CLion wizard. We could either open a project or we could just start without any project. But we could do open. So I have found the cmakelist.txt file ~kd/src/kcalc/cmakelist.txt. It says that I should open and asks if I want to open as a CMake project, which I do. I want to trust the entire ~kd/src directory. Okay, so we're at the open project wizard. I want to keep the defaults. We're going to override the default settings anyway for all of the projects that we build with kde-builder and then open inside the JetBrains CLion. These are the settings for kcalc. And in here we should edit. So there's two experiences when you open CLion. There's the very first fresh experience where you're greeted with wizards for configuring your license key, for configuring your integrated development environment, for configuring your CMake settings, for configuring your project, etc. But then after a while, you're just going to open the integrated development environment and start using the main menu for everything, for opening a project, for configuring the project, etc. Way more often we're going to use the main menu than the various helpful first run wizards are going to be displayed to us. Okay, so let's see how we do the configuring of the kcalc project in CLion using the main menu in CLion. So CLion main menu, unfortunately, the main menu is not shown by default, and I configure CLion to show the main menu always. But until then, we have this hamburger button with 4 vertical lines. Says File Settings Build. Settings. Build Execution Deployment, CMake. We need to select the profile named debug, which is pre-selected. And then we're going to provide the build directory in here. Okay, so the build directory is this one. So it's in the part cd in here after the line running CMake targeting Ninja. There's the CMake options. Let's provide that. So we do not need to specify the directory where the sources are, because that's specified by opening the cmakelist.txt file. We don't need to specify the current directory, so minus uppercase B, because that's specified here in build directory. So we will need the rest of the command lines, the command line. So from minus uppercase G until the end. And that we put in the edit box CMake options column. Okay. And then we also need the rest of the settings, which is just a list of environment variables. The environment variables start here and end here. Right click, copy. Let's get a text editor. Okay, so it says that we get this block. We copy it inside the text editor and then we do some string replacements. We're replacing this part with nothing. So many spaces and then the text setting environment variable space. And then we replace space to space with just the equal sign. Replace all button. Okay, then this content we should save as this name. So we should save as file tilde/kd/CLion-cmake.txt. Overwrite in my case. And then we need the content of this file, Ctrl-A, Ctrl-C, and put it in CLion, in build, execution, deployment, CMake setting, in the environment. So this is the environment edit box, this one. At the right hand side of the edit box, there's this icon where it says edit environment variables, shift enter. And in here, I use the button paste. And then just OK. And this is it. These are all of the settings. We just set three things: the build directory, CMake options, and environment. The CMake configure step has run correctly automatically. If you want to be extremely extra clean, you could delete the existing build directory. So tilde/kd/build/kcalc, but we don't need to. So in this directory, kd-builder has built twice kcalc. First when we have run kd-builder space kcalc, and then when we have run the modified command line, which is this one, kde-builder kcalc no src no include dependencies refresh build debug. And now when CLion has run the CMake configure step automatically, it has also written the generated config files and other files into the same directory, tilde/kd/build/kcalc. At this point, kcalc, the KD project, is loaded correctly inside CLion. The following will work: CMake configure by just using the buttons in CLion, building, and running and debugging. And then the rest of the IDE features, such as opening files, editing files, source code files, code highlighting, code structure, navigation, everything. But to be extra safe, because kcalc is a Qt frameworks application, doesn't really depend on many Qt plugins or doesn't use QML. So this is the very happy scenario where no other environment variables need to be set for running the generated executable. But then To be extra safe, we're going to configure such that CLion, when it runs or debugs the executable kcalc, it provides the correct environment variables. Again, kcalc, the executable, does not need them, can work without them correctly, because the LD library path is not needed, because we're building with our path. But for many other KDE applications and KDE libraries, especially the ones that are using QML, these environment variables are needed in order for the executable and debugger to run correctly. So let's do all of these steps also for kcalc, even though it's not strictly necessary. For all KDE projects, there are going to be the following directories: tilde/kd/src, kcalc in this case, where just git operations happen. There the git clone has happened. And then there's a second directory, tilde/kd/build/kcalc, where cmake configure will generate some files, where the Qt framework will generate its files, the mock, the UIC, the RCC executables, etc. And inside of this build directory, also compiling will take place, linking, etc. In there, a file will be generated by extra CMake modules, which is called prefix.sh, which sets the correct environment variables if you want to run the application kcalc as correctly as possible. So let's do this. Open a new terminal in console. We want to see inside the prefix.sh file, and let's see if it's as we expected. So export path, LD library path is commented out. Export xdg data dirs, config dirs, Qt plugin path, QML to import path, Qt quick control, style man path, SASL path. Yes, that's right. And now we're going to run this file prefix.sh. We're going to set these environment variables for the current terminal using source. We're using the bash text shell. So when bash has run source and then prefix.sh, it has configured inside the running process bash the following environment variables, and it has done the expansions, the environment variable expansions. So this $sign path was replaced by the current value of the environment variable path. The same for expanding LD library path and xdg data dirs, config dirs, etc. By running echo and then the value of the environment variable, we get the correct expanded by bash value for this environment variable, for instance, for path. So this was expanded by bash, and this is just the verbatim string path equals in here. So path equals, and then bash will expand the correct variable value of the variable path. So we need this entire block. And we're going to paste it inside this file, expanded prefix sh.txt inside tilde/kd directory. New, Control V, copy this file path, save as, Control V. Already exists, overwrite yes. We need the same text block, so we're going to copy it. And then let's do what it says in here. CLion main menu, run edit configurations, kcalc. So these are CMake targets of type executable. There are some XUnit style tests, and there's also the target for the main graphical user interface application that's inside the kcalc project, which is also named kcalc. This is what we select, and it's already pre-selected for us. Okay, and then it says environment variables, this thing. There's also a button at the right hand side of the edit box, and in here we're going to click the paste button and press button OK twice. So with this we have configured extra correctly kcalc. The exact same procedure should work also for QML graphical user interface applications. Let's continue by actually using CLion, not just configuring it. Let's see how we run the configure step again. There's this clear all button. There's this reload CMake project button. Let's see if the output from CMake configure is similar to the one from we cannot actually see. When we run kde-builder --debug, we want all of the output from kde-builder, but then kde-builder doesn't provide the output from the CMake configure step. It's hidden in here. It's stored in this text file, this log file. So let's see what it says. This is a short version of the output of CMake configure. Okay, the following optional packages have been found. So it's starting from here. CLang format 20, runtime, flex, ply, add, al, xml, gi. Okay. Optional, required. From what I see is the exact same output, and this is to be expected because CMake configure has been run identically both by kde-builder and also by the integrated development environment CLion. That's a really good thing. Okay, after we have run CMake configure, but this was a clean, complete rebuild style of CMake configure. The currently selected CMake target is also shown in the main toolbar with this combo box. The CMake build configuration is also shown in the main toolbar of CLion. So we want to run CLion, which means that it's going to build with CMake build configuration debug and CMake target kcalc. So let's click on the run button. We could also click on the build button. Let's see build. But again, if we run, it's going to see that it needs to run building. Okay, tool window for building. It's showing a shorter version of the output from Ninja. And then once the build is finished, the tool window for running is being shown, this one with run and then a tab for kcalc. It has run the correct executable from ~kd/build/kcalc/bin directory. It did not run the CMake install step, and put kcalc into tilde/kd/usr/bin directory. But it's enough for our needs. The application runs correctly. Previously, we have also run the kde-builder plasma integration and kde-builder frameworks, which means that kcalc will be able to find inside the tilde/kd/usr directory most of its dependencies, all of the KD frameworks.so files, all of the KD libraries, all of the KD themes, icon themes, Qt widgets themes, color schemes, etc. using Plasma integration. Okay. Next up, we want to debug kcalc. Let's just start debugging. There's a button for that. Debug kcalc, Shift F9. So it's running inside of the debugger. But there's no breakpoint, so it didn't stop inside a source code file. Next up, let's debug the process kcalc. Let's do that. So expand inside the tool window project kcalc tilde/kd/src/kcalc. Let's find the entry point. So that would be in top level. There's a file named kcalc.cpp. Let's see if we get the structure of the file in the tool window structure Alt7. We're looking for the C++ executable entry point, which is the main function. Let's put a breakpoint on the first line with source code inside the main body. So line 2923. And now we can start the debugger. Nothing has changed. I'm not sure exactly why it needed to build anything. But again, it's doing a build, not a rebuild. It's going to be extra fast. If you didn't change files, it's going to just confirm that all of the translation units are correct, and building, not rebuilding, will be really fast. Okay, so we're inside the debugger, inside the integrated development environment JetBrains toolbox, in the file kcalc.cpp, where the C++ entry point, the function main, is defined. We're shown the values for the parameters and for the local variables, both inline, similar to comments, so grayed out. Let's see the shortcuts for debugging. In here, in the debug tool window in the tab kcalc. Resume F9, step over F8, step into F7, step out, Shift F8. But since I'm not familiar with the JetBrains style key bindings, I'm going to try to set the CLion to use the key bindings for Visual Studio. Let me do that. So on my wiki page says keyboard layout, CLion main menu, file settings, key map, and I want Visual Studio in this combo box. Apply, okay. I also want the main menu to always be shown. Let's see how we do that. Appearance. So in the settings, appearance and behavior, appearance, UI options, main menu, hide under hamburger button, show above main toolbar. Okay. Restart. Always terminate when I stop the integrated development environment. Always stop the running debugger. Okay, so back to where we were. We have CLion running. We have the breakpoint set on the correct line. If the kcalc project is loaded correctly, we can just start debugging. So Ctrl F5 and Alt F5 don't really look like Visual Studio shortcuts. Let's hide the structure and the project. Okay, let's look at the shortcut. So F10, that's a Visual Studio shortcut. F11 and Shift F11. Okay. So if we step inside the Qt source code, we can't really, but we can step into /usr/include. We have Qt installed from the Linux operating system. So this operating system is Ubuntu 25.04. I have installed Qt, including all of the development packages, using deb packages from Ubuntu. So everything that's Qt is installed into inside the /usr, and all of the other non-KD libraries are also from /usr installed from deb files, but then all of the KD libraries, frameworks, etc. is from kde-builder, built from the master Git branch. So for the Qt framework, we only have the .h files, which are from /usr/include, but there are some methods implemented in /usr/include, such as this one, const expr constructor no except. Okay, what I really want is to go to the constructor of k-about-data. So it's jumping inside /usr/include, which I do not want. But then hopefully at some point we will get inside the constructor of k-about-data, which is both inside tilde/kd/usr/include and also inside tilde/kd/src/ I'm not sure where k-about-data comes from. Let's see if Shift F11 works, and it does. So I run F11 to step into. I see that it's stepping inside the place where I do not want, so I go Shift F11 to return. F11, Shift F11, 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 Shift F11, F11, Shift F11 a million times. And at long last, we are where I wanted, which is Kcore add-ons, which is a KD framework. tilde/kd/src/kcore add-ons. And we're also inside the CPP file where the implementation is. So this is the constructor. It uses a d-pointer, a pimple. We can step into that and see what's it doing. And this is what we wanted to see, the constructor of kde-builder. Let's get more space. We have the debug tool window, Alt 5, which is available in the left-hand side panel. We have a tab for the running kcalc process. We have the buttons for managing the debugger. We have a tab for threads, where we can see that we're in the main GUI thread of kcalc. And the call stack in there is the kcalc.cpp main function line 2939. And then from there on, we're inside the constructor of kde-builder in kde-builder.cpp line 583. So this is the call stack. We have local variables. We have this p, which is -1 integer. D is hidden under this. The debugger displays correctly Q strings. Let's see if it displays correctly Q lists. And it does. We can see enums. We can see Q strings. A ton of pimples. License list. About license, etc. So the debugger seems to work correctly. You can expand as much as you want the variables. There's a correct visualizer for some cute types. We saw some for the cute containers and for QString. Visualizer for QURL. Okay, it jumps into QString, which is not great because I'm pressing F10, which means it should remain in k-about data, not step into QString. Okay, so we're out of the constructor for k-about data. Let's see what we have here. So a GDB console. Let's see if this actually works. At the end of the page says that inside the debug Alt 5 tool window, there's a tab for GDB where we can run GDB commands. Let's run infoproc. And it works correctly. Okay, so at least infoproc works correctly inside the GDB console, where you can run GDB commands. So we have the process ID, this one with 83,000. And then it says that inside the terminal, we can run this command line. Let's see the integrated terminal inside CLion. This button, tool window terminal, Control Alt 1. Paste. Let's paste the process ID. And then environment. There's auto completion. These are all of the environment variables inside the environment of the running process kcalc. And what we want to do is to compare them with the values from expanded prefix -sh.txt file and see if they're identical. So first, the environment variable path. The environment variables are not shown alphabetically. Path. Okay, so starts with tilde/kd/usr bin, tilde/.local/bin, /usr/local/bin, and ends with toolbox scripts, correct? Then xdg data dirs, this guy, starts with tilde/kd/usr/share, then flatpak, ends with snapd desktop, correct? Xdg config dirs, where is that? This guy xdg config dirs starts with tilde/kd/usr/etc/xdg, ends with kf5 minus settings, correct? Qt plugin path. Let's use sort. Xdg config dirs starts with tilde/kd/usr/etc/xdg, also ends with kf5 minus settings, Qt plugin path, just one value in there, tilde/kd/usr/lib. Okay, QML to import paths. This thing ends with /qml, similar to the previous one. Qt quick controls style path ends with Ctrl+2, correct, and man path should start with tilde/kd/usr/share/man, correct. So again, we proved that the kcalc process runs with the best environment variables possible. And from here on, it's just how much expertise you have with using CLion. I don't have much, but again, we have loaded the KD kcalc process correctly. It was built previously using kde-builder, and now we have opened it in CLion in a very, very similar way or an identical way to how kde-builder configures, builds, and installs it, and then runs it. Let's see how we stop the debugging. The debug tool window. So there's buttons for stepping over. There's no need to use the shortcuts if you don't want to step out, step over, step out. You can delete all of the breakpoints. There's a breakpoints tool window, which is very important. I use breakpoints also as a to-do list. The important parts of the application, I put some breakpoints there, and then all of the integrated development environments that I have worked on do have breakpoints. Some integrated development environments have additional ways of highlighting lines. There's to-do comments, there's bookmarks, etc. But breakpoints always exist in all integrated development environments, so I use them for that purpose. Let's see if go to definition works correctly. Control-click on add author. It goes to the definition, so the .h file in tilde/kd/usr/include. That's correct because the debugger knows where the CPP files are, but the integrated development environment doesn't really know where the CPP files are or other Git projects than kcalc. So the kcalc Git project depends on this Git project, which is called kcore add-ons, which has put the build artifact, so the .h files in tilde/kd/usr/include, the so files in tilde/kd/usr/lib. So all of these were made by the install step of kde-builder when it built this Git repository kcore add-ons. So you need to always keep in mind that the debugger does get access to other repositories CPP files, whereas when you're outside of the debugger, you don't actually get access to those. So again, this is for source code from outside of the project that's loaded in CLion. Internationalization, so I18N is a free function, C++, inside tilde/kd/usr/include from the kd git repository k18n. We can see the function definitions. Control W doesn't work by default, which is not great. Let's go back to where we were. Kcalc. If we hover on top of a identifier, we can see documentation. Says from which file it comes. Jump to source. We can scroll through this tooltip, so it's not really a tooltip, it's an enhanced tooltip. You can also resize the tooltip. Signature and doc strings. You can navigate URLs. Okay, there's this feature where it shows you the parameter names, not just the parameter values. So this name column, task column, text column, email address column. There's this, it shows you that you're inside the debugger, your post here using this right facing arrow, but then you also have, as similar to a comment, the current value of the local variable, which is about data. Okay. Again, we have the structure of the currently opened source code file. Everything seems to work okay. There were 0 crashes. I cannot find an issue here. Let's go to kcalc. I don't know how to use the Git integration into any integrated development environment. I always use the graphical user interface for Git that's part of the Git project, which is git -GUI and git-k. So git space GUI command line, which is this thing. I can fetch. I can see the entire history. I can see that the current Git commit where we're at is the local master branch. and it's pointing to the same git commit as the remote origin master branch. So there's also to-do points and bookmarks in this integrated development environment. Okay, and another tool that I find useful in CLion is the problems inspector. Let's see that. So let's stop the debugger, debug, stop. The problems Alt-6 tool window. And we can inspect code, whole project, analyze. It's going to take a while. It's showing issues as it encounters them. Let's wait a bit. Okay, so take everything you see here with a grain of salt, because it has also looked inside tilde/kd/build/kcalc, which is not really source code files. It also looked at the test data for XUnit style tests. It's going to find typos for just various C++ identifiers. So there are some issues which are real and are fixable and make for really quick and good KD merge requests, but then many of these you should just learn to ignore. Task can be made final. Wow. So 28 classes can be made final. I'm not sure what to say. Declaration and assignment can be joined. kcalc.cpp. Yes, it does make sense to unite these two lines, 1720 and 1721. Here also, yes. So this warning is a good thing. Function returns const value. Consider returning by non-const value instead. And I don't know why. Where do we find more information about this thing? I don't know. It should have a context menu in here. Go to the documentation of this warning. Functional style cast is used inside C++ cast. Okay, and there's also quick fixes, right? So it suggests that you replace button mode flags round parentheses with static cast less than button mode flag and then greater than and then parentheses. I'm not sure what to say about this. So first of all, you will need to create a test application where you actually test that the two are perfectly identical. And then you will need to see if there are precedents in one of the KDE Git repositories for doing such a thing, for going static cast and then bit flags. Flag enums. Local variable can be made const. Val can be made const. I don't know what this thing is about, but you could try. Make this QString, which has a very limited time span, const and see what happens. Insert token numeric. So this using a QString const reference. I know. I totally do not know. I have never used in C++ const just randomly when a thing is not a string literal or something, an integer literal. Member function can be made const. I don't know this either. Member function can be made static. I'm not a fan of static methods. Non-explicit converting constructor. And the fix is to add explicit keyword. From what I know, there's a ton of precedent for using the explicit for constructors. So again, do look in other KDE Git repositories, see if there's heavy usage of explicit for constructors. And if that's the trend, then, and if adding explicit doesn't provide any regression, then you could do that. Yes, there's material for many correct merge requests, small ones, which will actually get merged. So non-ref, non-const, QAbstract button. Because it's an in-out parameter, right? No, it's actually not. It's just fetching the ID. So button is only used for computing the ID. Yeah. A ton of material for merge requests in here. It gets the document element, but then what does it do to it? First child and then element. So just reads. I'm not sure what to say about this. Colors can be made const. Colors can be made lowercase. Why would it be uppercase K, uppercase C? But then it's inside a UI underscore.h file, which is generated by UIC executable. So don't ever edit files inside tilde/kd/build directory. There's no point. They're just temporary files which are going to be overwritten when you do a full rebuild with a clean CMake configure. You can pass parameter that's already const also by reference. Reinterpret cast instead of static cast. I'm not sure what that is. Build time constants. Make sure you're not editing libraries that provide ABI. So don't change the application binary interface, the application programming interface in KD libraries. If those symbols are exported and are expected to be used by other projects or are actually used by other KD Git repositories. But const expr instead of defines and instead of const int do make are reasonable. Again, if you don't change the API ABI for exported symbols that will be used in other places. If the symbol is just being used inside this KD Git repository, you can make sure of that. Then you can try to replace const with const exprs. But then also inside the body of a function, why should you do that? Yeah, for members, for free constants, I could understand that, but for local variables inside the body of a function, I'm not sure why. Variable can be moved to if. So says that C is only used on the then branch, so move it inside of the if. Nope. Can be moved probably here inside the condition, which is not something I would recommend. Yeah, so it suggests that you create huge, impossible to read by humans if conditions. Don't do that. Variable can be moved to inner scope. No, it cannot. The same thing. Bloating the condition in switches and ifs. That's not a good idea. Compiler issues. There are no compiler issues. What compiler issue? Again, make sure you're not editing the MOC underscore files because these are also from tilde/kd/build directory are generated by the Qt framework's executable MOC. Memory allocated which is not released. It's not really easy to determine if a memory allocation escapes and is leaked because you're using the C++ programming language and you're using the Qt framework, which makes heavy use of parents, and parents have the habit of releasing the memory of their children. When, for instance, you're using Qt widgets and you're setting the parent of a button to be something else, a window. So take all of the memory leak reports with a major grain of salt. Because again, in here you're using add layout. And it's using Qt widgets. So you can probably ignore these. Conditions that are always true or false. Based on what? Condition is always true when reached. Because there are no more possibilities. Yeah, but then when you add a new possibility, then all of a sudden this condition makes sense. Inspection timed out. Invert colors is unreachable. How do we go to its definition? Go to declaration or usages F12. Where is this thing defined? in kcalc display.age as private and used in two places. All calls of function invert are unreachable. I'm not sure. So this is flow analysis, and it should say this if can never be reached because these variables, these local variables already have these values when the code is reached or something. Return value is always the same from this function. So I see a 0 and 0 and always 0. Yeah, so this int is just for future purposes. Okay, typo rearranges 1 and 2. Great, this totally makes for a merge request material, and I'm going to do this merge request. Okay, so this was the JetBrains CLion IDE, very powerful C++ IDE, one of the best 10 C++ IDEs for Linux. I didn't have any issues, crashes with this application yet. Is fast, snappy, does support kde-builder, does support Qt, does support KD, has powerful navigation features, the debugger works correctly, running, compiling, rebuilding, incremental building, all of the things I could think of, and I know how to use in CLion, I have used, work correctly. And then there's also this powerful inspection tool which inspects the entire project, uses many different tools to do static analysis of the source code, and analyzes various source code file types, not just C++, but also YAML, Python, JSON, etc. This is it. Thank you.